Hi everyone, welcome back. In today's video, we are going to use Google Earth Engine to study how land surface temperature has changed across West Africa from 2000 to 2023. This is important because rising temperature affect agricultural availability and urban living condition. So the data set that we are going to use is MODIS 11A2. That is a global data set that provides land surface temperature every 8 days at 1 kilometer resolution, and the values are stored in Kelvin, so we can convert them to degrees Celsius by multiplying 0.02 and subtracting 273.15 as constant when calculating for land surface temperature. So let me show you. Let me show you where. So this is the constant. So we will multiply the data by 0.02 and then we subtract 273.15 from it, and then as we can see we are using West Africa, that's our study area, and then we are focusing on daytime land surface temperature, but you could also run the same analysis with nighttime data. So you just have to change this day to night so that you can just get your night land surface temperature. So it's very simple. If you want night time land surface temperature, you can just change this one to a night so that you can get your night temperature. And then the last one is our export code. As you can see, we have our export here, which we are exporting our map in CSV. As you can see, we are exporting our LST annual mean West Africa in CSV format, as you can see here. So let's quickly get into it. So after getting all your scripts ready, we are going to run our script and then see. So for each year 2023, we are going to take the average of all MODIS image and create one composite image. So we are going to take the average of all MODIS image that was captured in a year and then take the average of that image. That will give us the mean land surface temperature per year. So this one we are using a year, so we are going to take the average and then get the mean land surface temperature per year. Then we will calculate the mean value for the whole region for each year and build a time series chart. Finally, we will perform a linear regression on the pixel value across time and then produce slope map. So this is our code. So let's run it and see the results. So if you want to run, it's very simple. You just have to click on run. So as you can see, this is our study area in West Africa. So all the country that in West Africa, you can see it has been highlighted here. So this is our West African map. Alright, so you can see on our layer we have our West Africa ROI, that's our study area. Then we have LST for 2000, and then we have LST for 2023. So as I was saying, we will calculate we will find the mean, the average of LST for 2000 and the average LST for 2000 for the whole year, and then we calculate for the mean, as I have already told you. It's the same as we are creating a composite. So we create a composite for all MODIS data in 2000, and then we create a composite for all MODIS data in 2020. Then we find the what do we call it, the mean of that composite. So as you can see, we have our LST trend, that's in degrees Celsius, and then we have LST 2023, and then we have LST 2000. So let's visualize it and see how it looks like. So this is our LST 2023, as you can see here. Okay, so we have our LST 2023, and then we have our LST, as you can see, ranging from 15 degrees to 45 degrees here, and then we have our LST 2000 here, as you can see. we have our LST, and then if you look at here, we have our annual mean LST, that's the 2023. I'll expand this one so that you can view it well. So this one too ranges from 15 to 45, which we can change it here. We can stretch it to 90 degrees. So let's stretch it and see. Alright, so as you are visualizing the map, you can see at the southern portion of Africa, we have a very cool temperature which has a low LST value. So as you can see, all the green spaces here has a low land surface temperature, and then we have a middle that is around 30 degrees there, and then here is the higher temperature where we have the higher sun radiation, and then where the solar radiation is high at the top here. So this place is the Algeria, and then the rest here, and then we have Ghana, and then Nigeria, and then Cote d'Ivoire around this place. So where we have the forest region, we have low land surface temperature, and then where we have the savanna, we have a higher land surface temperature here. So as you can see, so let me visualize the changes so that we can see that one too. Okay, so this one is just showing us the changes that has been occurred. So in area where we are, the area in red indicate a positive slope, meaning land surface temperature has been increased over time. So as you can see at this place where we have a low land surface temperature, as we visualize on our map here, the land surface temperature has been increased over time, but at the northern part of the of West Africa, land surface temperature has been stable for a while, and then area in blue indicate a negative slope, meaning land surface temperature has been decreasing. So the blue place meaning land surface temperature has been decreasing, and then this place means land surface temperature has been increasing, and then the white portion means land surface temperature has been remained the same or no change has been occurred. So let's let me visualize this one so that you can see. So this is the annual mean LST West Africa 2023. So as you can see, we have our, so in 2000 our land surface temperature was around 37.5, and then it fall from 37 to 36, and then as you can see it fall again in 2000, then it fall again in 2023, and then as you can see the trend. So in 2023 our land surface temperature was almost about 35.83, which is the highest temperature in 2023. But in 2000 the land surface temperature was around 37.5. so as we visualize it here, you can see everything here. So this is how we calculate for land surface temperature across Africa, and then using the MODIS data, and then you can use other data sets to calculate for land surface temperature, but to use the MODIS data, this is how you calculate for your land surface temperature. So thank you very much for your attention, and if you have any question or complaint, please do well to leave it on the comment section so that I can answer you. Thank you very much for your attention.